Bismillah ar-Rahman ar-Rahim. Welcome to Target Educational Channel. Today we discuss about the matrices and determinants. First of all, we discuss about the definition of the matrix, a rectangular array of real numbers in rows and columns. And one example is given. These elements mean 1, 3, 4, 7, 2, 0. These are arranged and enclosed in a bracket. This is known as a matrix. The matrices are oftenly denoted by the capital letter of the English alphabets. Let's take another example. For example, in a school, there are 3 levels like section 1, section 2 and section 3, and their students are boys and girls. If we see boys in a section 1 are 194 and boys in section 2 are 125 and the boys in section 3 are 198 and the girls in section 1 are 193 and the girls in section 2 are 202 and in section 3 girls are 203. If we enclose or if we write these elements in brackets 194, 125, 198, 193, 202 and 203, and these are enclosed in a bracket. So this is the matrix form. Now rows and columns. Rows, if the entries are represented in horizontal way, these are known as the rows. See, in this matrix A, the elements from left to right 1, 2, 0, this represent the row number 1, and 3, 5, 4, it is represented by R2, mean row number 2, and 2, 1 minus 1, it is represented by R3 because it is row number 3. Now as concerned to the columns, these are the entries which are represented vertically. In 203, this is column number 1, 312, this is column number 2, and in the same way the vertical arrangement of the elements 5, minus 1 and 1, it is represented by column number 3. Now order of matrix. The number of rows and columns in the matrix specifies its order. For example, if there is a matrix has m rows and the number of columns are n, then we say that the order is m by n. Mean first of all we represent the number of rows and then number of columns. See, for example, there is one matrix which is represented by capital letter M that have elements 1, 2, 3, 1, 0, 2. Now if you see the arrangement of the element horizontal way, so there are 2 rows, row number 1 and row number 2. As concerned to the columns, there are 3 columns, column number 1, column number 2 and column number 3. So we can say that its order is 2 by 3. Next we take another example. See how many rows. First of all we have to mention the number of rows 1, 2 and 3. There are 3 rows and number of columns mean the arrangement of the elements in a vertical way 1, 2, 3. So in this matrix there are 3 rows and the number of columns are also 3. So we can say that the order of this matrix is 3 by 3. Next, there is another matrix P that have elements 3 to 5 and these elements are written in a horizontal way, mean there is only 1 row but there are 3 columns. So we can say that the order of this matrix is 1 by 3 because there is only 1 row and there are 3 columns. Equal matrices. two matrices are equal, let A and B are two matrices, then A is said to be equal to B if and only if the order of A, mean order of the matrix A, that is equal to order of the matrix B. Number two condition is their corresponding entries are equal. Then these matrices are known as the equal matrix. For the corresponding elements, see, I want to take one example. For example, this is matrix P and this is matrix Q. If we mention the, first of all, if we mention the number of rows, mean this is row number 1, and in this row number 2, and if we give the name, the number to the columns, this is column number 1, and column number 2. In the second matrix, row number 1, row number 2, column number 1, column number 2, and column number 2. Now we can specify the position of this each element. The position of this element is that is located in this A11. It means this is this position of this element is that is in row number 1 and column number 1. See, in this second or in the Q matrix, the position of this element is row number 1 and column number 1. So these are known as the corresponding elements. If we consider this, the position of this element is row number 1 and column number 2, and here row number 1 and column number 2. So we can say that these are also the corresponding elements. Here the row number 2 and column number 1 and its corresponding element is this, and for this A22, it's mean row number 2, this represent row number 2 and column number 2. So this is the corresponding element is this. So we can say that because according to the condition number 1, the order of A that must be is equal to order of B. So see, in this matrix A, the order is 2, there are number of rows are 2 and number of columns are 2. So its order is 2 by 2. In second matrix, the order is 2 rows and 2 columns. So its order is 2 by 2. And let's see, let's compare their corresponding elements. 1 is equal to 1, 3 is equal to 2 plus 1, that is also 3. So minus 4 and minus 4, and 2, that is equal to 4 minus 2, that becomes 2. So all corresponding elements are equal and their order also equal. So these two matrices, mean matrix A and matrix B, these are known as equal matrices.